We're on to question 8 now. The question comprises of a Ferris wheel which generates a trigonometric function, and in part A we need to fill in the table. So the first part will be setting our calculator to radians, inputting the values of t into our formula and filling out the full table. So let's see what we get. So there's the range of outputs h of t. They're all the heights for the cycle. So make sure you set your calculator to radians. When we sub in 0, we're going to get 72 minus 60 by cos of 0, which is 1, and 72 minus 60 will give 12. And carry on with that process. So let's look at the next part. So we need to use the table to plot the sinusoidal graph. So for instance, when we go to the max here, that coincides with the 132. So plot it out and you can see it's a cyclic function. It will go from the minimum up to the maximum and back down again. As we have the function, we need to find the period and the range. So let's first of all find the period of the function. And you can see here that the period is the full cycle. So from the starting point all the way to the same point again is one full cycle. So if we check the values on the x-axis or the time axis down here, we can see it will take 6 minutes to complete the full cycle. So the period is 6 minutes. If we're finding the range, well, the range is the difference between the maximum and the minimum. So we can see that the range values are, the max is 132 and the minimum is 12. The difference between the two values is 120, which can also be considered the range as well. So there's our answers. The period is 6 minutes for the cycle and the range is 132 for the max and 12 for the minimum. So during a 50-minute period, what is the greatest number of minutes for which point A could be higher than 42 minutes? So 50 minutes is considerably more than one cycle, as each cycle is 6 minutes. So we could divide 6 into 50, but there's another specification here. We need to get the greatest number of minutes. So we can move the time interval to maximize it. So let's see how we can do that. So let's observe the cycle. So at minute 1 in the cycle, it will exceed 42 meters. So it'll come back around and it will go under 42 meters at 5 minutes. So we have a total of 4 minutes it will be above. So if we start at minute 1, we can get the first 4 minutes. So if we do that for another 8 cycles, we can go up to 48. So we start at 1. So at 1, we will have the first cycle. So we'll have at 1, 4, and let's keep going in for 8 cycles. So 4 by 8 is 32. So that will take us up to 48 minutes. And then we're going to plus in another 2 minutes. So it's at the end over here at the 48. It will be back at here at the starting point. Okay, so if it started there, it will resume the next cycle. So 1, 2. So the next 2 minutes then will also be greater than 42 of height. So plus an extra 2 minutes. So on to 50. So we're going to get an extra 2. So plus 2 minutes of the start of a new cycle. So I'll be up to 50 minutes. Okay, that's our timeline there. So the total then will be 34 minutes. So very straightforward. 8 cycles starting at 1 minute, and then we will generate 32 minutes above 42 meters height, plus the extra 2 then at the start of the last cycle, which is just a part of a cycle. And that's your answer. So finally we need to do integration, and we need to get the average height. So this average height indicates that we need to use the average value theorem. So let's see what the average value theorem is. So here it is. So we can get the width of the interval, that's 1 over b minus a, and the upper limit is b, which would be the 8 in this case, and the lower limit would be 0 as we're doing the first 8 minutes. Okay, so let's get started. So when we're doing our integration, we need to integrate our cosine function. So let's look up our log tables firstly. You can see over here in integration, the cos will go to sine. Alright, so we have everything we need now to work this out, and let's get started. So this is the start of the average value theorem. 1 over the width, b minus a, multiplied by the integral of between the upper limit and the lower limit, b and a, of the original function with respect to the time. So let's substitute in our function and evaluate our integral. So we're going to get 1 over 8. Let's integrate this. So 72 becomes 72t, and minus cos 60 pi over 3t will become minus 60. The cos will go to sine, as we've seen earlier, page 26 of your log tables. Retain the value inside the period, pi over 3t, and we're going to divide then by pi over 3, as it's an internal function. So pi over 3 goes below here, very similar to the chain rule. And we're going to put in our plus c here and indicate our two limits then, b and c, which will be 8 and 0. Alright, so that's our integration completed. Now we need to evaluate the value of the height. So we will retain the 1 over 8 outside. Let's work out in the center and substitute the 8 and the 0 in. So we'll get 72 by 8 minus 60 sine pi over 3 multiplied by 8 all over pi over 3. Here we can leave it like that. Okay, and then we're going to go with minus 0, because if we sub in 0 in for our t and for our t over here, we will get two values of 0. So we can just write, to save some workings, 0 over here. Okay, so let's multiply it out with your calculator, and we will get the h average as 65.79, which is 65.8 when we round it to 1 decimal place. And that will be in meters. So let's look at that on the graph. You can see there, it's there pretty central, as it's a very balanced graph. And that's it for question 8. Thank you for joining Maths Plus.